Imagine standing at the edge of the universe's greatest mystery, peering into the moment when everything began. Deep beneath the border of Switzerland and France, a machine hums with the power to do just that. It's called the Large Hadron Collider, or LHC, a 17-mile ring of superconducting magnets buried underground, the biggest, boldest particle smasher humanity has ever built. This isn't just a tool for scientists in lab coats. It's a time machine, a cosmic key that could unlock the secrets of how our universe came to be. But with that power comes a question that keeps even the brightest minds awake at night. What happens when we push nature to its limits? Could we accidentally unleash something we can't control? Picture this: protons, tiny bits of matter, zipping through the LHC's tunnels at nearly the speed of light. That's 299 million meters per second, fast enough to circle the Earth 7 times in a blink. These particles race through a vacuum colder than outer space, guided by magnets stronger than anything we've ever created. When they collide, they don't just bump into each other. They explode with energy so intense it mimics the conditions of the Big Bang, the moment 13.8 billion years ago when the universe burst into existence. Temperatures soar hotter than the core of the sun, and for a fleeting instant, we're back at the dawn of everything. It's like holding creation itself in the palm of our hands. This colossal machine belongs to CERN, the European Organization for Nuclear Research, a place where the world's smartest minds gather. Founded in 1954, CERN is a beacon of human curiosity, uniting 23 countries and thousands of scientists, engineers, and dreamers. They're not just chasing equations, they're chasing the fundamental truths of reality. The LHC is their crown jewel, but it's only part of a sprawling network of accelerators and experiments, a racetrack for particles that pushes the boundaries of what we believe is possible. At 4 points along the LHC's ring, massive detectors, ATLAS, CMS, ALICE, and LHCb, act like giant cameras, capturing the chaos of these particle collisions. Each one hunts for something different, from the elusive Higgs boson, nicknamed the God particle, to clues about dark matter, the mysterious stuff that makes up a quarter of the universe. Let's talk about the Higgs boson for a moment. Discovered in 2012, it's the particle that gives everything mass, the glue that lets matter stick together to form stars, planets, and us. Finding it was like uncovering the blueprint of the cosmos, a triumph that proved the LHC's worth. But every answer raises new questions. What else is out there? Could there be particles or forces we've never imagined? The LHC smashes protons together to create showers of debris, and scientists sift through the wreckage, looking for patterns that could rewrite physics. It's like searching for a single sparkling gem in a mountain of sand, but when they find it, it could change how we see the universe. Now, here's where things get wild. The LHC isn't just about discovery, it's about power, and power comes with risks. Imagine the energy of those collisions bending space and time, like dropping a heavy stone onto a trampoline. Some theories suggest that at these extreme energies, the LHC could create a mini black hole. Yes, a black hole, those cosmic monsters that swallow stars and trap light itself. The idea sounds like science fiction, but it's grounded in real physics. If extra dimensions exist, as some string theorists propose, the LHC's collisions could compress energy so tightly that it forms a gravitational point, a tiny black hole. Scientists at CERN, including Brian Cox, a physicist who's worked on the LHC, insist these would be unstable, evaporating in a flash of energy called Hawking radiation. But the mere possibility sends shivers down spines. What if they're wrong? Could a tiny mistake grow into something that swallows the Earth? This isn't just theoretical fear-mongering. History gives us a sobering reminder of how dangerous particle accelerators can be. In 1978, a Russian physicist named Anatoly Bugorsky was working on a smaller accelerator when a proton beam shot through his head. The beam, moving at nearly light speed, burned through his skull, yet he stayed conscious, even walked to get help. He survived, but lost hearing in one ear and suffered facial nerve damage. His accident is a stark warning. The forces we're playing with are real, and they're unforgiving. The LHC operates on a scale far beyond that machine, amplifying both its potential and its perils. Then there's the even scarier idea of vacuum decay. Picture the universe as a vast, delicate bubble, held together by a balance of forces. Physicists like Stephen Hawking and Sir Martin Rees have warned that the LHC's high-energy experiments could, in theory, disrupt this balance. If the Higgs boson becomes unstable at extreme energies, it could trigger a chain reaction, a cosmic unraveling that spreads at light speed, wiping out everything, not just Earth, but the entire universe. CERN's researchers call this risk vanishingly small, backed by rigorous safety tests and calculations. They point out that cosmic rays, natural particles from space, hit Earth with similar energies all the time, and we're still here. Yet the stakes are so high that even a tiny chance feels like too much for some. The LHC also fuels speculation about opening doors to other dimensions. String theory suggests there could be hidden dimensions curled up at scales too small for us to see. When protons collide in the LHC, they release energies never before created in a lab, potentially sending ripples into these unseen realms. Could this open a portal to another universe? Most scientists scoff at the idea, calling it a Hollywood exaggeration. But the public's imagination runs wild, fueled by movies and news stories that paint the LHC as a gateway to the unknown. What if something slips through? What if we're not alone in the cosmos, and the LHC accidentally invites something in? These fears, while gripping, don't tell the whole story. The LHC is a testament to human ingenuity, a machine built not just to answer questions, but to ask them. It's the result of thousands of minds from across the globe working together, a rare example of unity in a divided world. CERN scientists aren't reckless madmen. They're meticulous, constantly monitoring and refining their experiments. They've developed safety protocols to ensure the LHC operates within known limits, and they're open about the risks, however small. Briancox has said it best. The LHC is about exploring the edge of what's possible, not gambling with existence. Beyond the science, the LHC's impact ripples into our lives in ways we might not expect. The sheer volume of data it generates, millions of collisions every second, has pushed computing to new heights. CERN invented the World Wide Web in the 1990s to share this data, and today, its global network of supercomputers drives advances in artificial intelligence and machine learning. Discoveries about particles could lead to breakthroughs in medicine, like better imaging for cancer treatment, or in nanotechnology, creating materials stronger than steel. The LHC isn't just about abstract physics. It's about building a future we can't yet imagine. The machine also inspires us culturally. It sparked books, films, and TV shows, turning terms like quarks and bosons into dinner table talk. This fascination isn't always accurate. Media often amplifies fears of doomsday scenarios, but it gets people curious about science. The LHC has become a symbol of humanity's ambition, a reminder that we're not content to sit still and accept the unknown. It trains thousands of students and researchers whose skills spread into industries like computing, electronics, and even finance. It's a beacon for the next generation, showing that science isn't just about answers, it's about daring to ask. Yet, as we marvel at the LHC's power, we're forced to confront deeper questions. Why do we do this? Are we chasing knowledge for its own sake, or is there a greater purpose? The LHC probes the fundamental forces, gravity, electromagnetism, the strong and weak nuclear forces that shape reality. It's trying to answer questions humans have asked for centuries. What is matter made of? How did the universe begin? What holds it all together? But with each discovery, we face new uncertainties. The Higgs boson confirmed part of the standard model of physics, but it also hinted at gaps we don't yet understand. Dark matter, extra dimensions, or new particles could be just around the corner, waiting to upend everything we think we know. This brings us to the ethical heart of the LHC. With the power to manipulate the building blocks of the universe, we have to ask, should we? If we create new states of matter or tap into unknown forces, who controls how that knowledge is used? Should there be global rules for experiments this extreme, like treaties for nuclear weapons? The LHC's discoveries could lead to technologies we can't predict, just as quantum mechanics gave us smartphones. But they could also bring risks we can't foresee. Science has always walked this tightrope, balancing discovery with responsibility. The LHC is no different. It's a leap into the unknown, driven by our need to understand. Perhaps the LHC's greatest gift isn't the particles it finds or the theories it proves. It's the way it forces us to look at ourselves. When we peer into the subatomic world, we're also searching for meaning. Are we decoding the universe because we can, or because we believe it holds answers about who we are? The LHC reminds us that the smallest particles can spark the biggest questions. It's a machine, yes, but it's also a mirror, reflecting our curiosity, our courage, and our flaws. Every collision in its tunnels is a chance to glimpse the heart of reality, to touch the forces that made the stars, the planets, and us. So, as the LHC hums beneath the Earth, smashing particles and chasing secrets, it carries us forward. It's not just a tool for physicists. It's a monument to what makes us human. We're explorers, driven to push beyond what we know, even when it scares us. The risks are real, but so is the promise. With every experiment, we're not just uncovering the universe's past, we're shaping its future and ours. The Large Hadron Collider isn't just rewriting physics. It's rewriting what we believe is possible. And in that collision of science and wonder, we might just find the answers we've been searching for all along.